Lagrangian mechanics is a reformulation of classical mechanics that's based on the principle of least action. In Lagrangian mechanics, we use energy and a quantity called the Lagrangian instead of forces, like in Newtonian mechanics. The Lagrangian, denoted as L, is defined as the difference between the kinetic energy, T, and the potential energy, V, of the system. Mathematically, it's expressed as L equals TV. To describe the system's configuration, we use generalized coordinates, denoted as q_i. The time derivatives of these coordinates are the generalized velocities, denoted by q_i dot. The equation of motion in Lagrangian mechanics is the Euler-Lagrange equation, shown here. It relates the partial derivative of the Lagrangian with respect to the generalized velocity and the partial derivative of the Lagrangian with respect to the generalized coordinate to describe the motion of a system. Now, let's move to Hamiltonian mechanics. This formulation uses a quantity called the Hamiltonian h, which represents the total energy of the system. The Hamiltonian is a function of the generalized coordinates, q, generalized momenta, p, and time, t. It's defined as shown, where p_i are the generalized momenta, q_i dot are the generalized velocities, and L is the Lagrangian. The generalized momentum associated with a generalized coordinate q_i is defined as the partial derivative of the Lagrangian with respect to q_i dot. The equations of motion in Hamiltonian mechanics are Hamilton's equations. The first equation states that the time derivative of the generalized coordinate q_i is equal to the partial derivative of the Hamiltonian with respect to p_i. The second equation states that the time derivative of the generalized momentum p_i is equal to the negative of the partial derivative of the Hamiltonian with respect to q_i. In summary, Lagrangian mechanics uses the Lagrangian, L equals TV, and the Euler-Lagrange equation, while Hamiltonian mechanics uses the Hamiltonian, H, and Hamilton's equations to describe the motion of a system.